This is video 7.04, and the title of this is Inheritance Patterns. One of the things you need to be able to do both in this class and for the end of the year test is to look at a pedigree and decide what the inheritance pattern is. So the three that we have to choose from, the three inheritance patterns that are most common are autosomal recessive, autosomal dominant, and sex-linked. And each one of the pedigrees for these look a little bit different. So we're going to look at an example of all three of these and talk about the tells, the way that you can tell that a pedigree is either autosomal recessive, and by that we mean the trait. So this is, or the disease. The trait is either autosomal recessive, it's autosomal dominant, or it's sex-linked. Now, I think that sex-linked, and that's what we have here, is one of the easiest to tell. So what we have here is the pedigree for Queen Victoria. So this box says Victoria of England. And when we talked about, excuse me, the royal family of Russia, which is here. This is Tsar Nicholas II. This is Alexei. This is the little boy that Rasputin was hired to heal. And this is his mom. And you can see that his mom is descended from, she's the granddaughter of Queen Victoria. But what happened was Queen Victoria was a carrier. So her genotype would have been, remember we said for hemophilia, capital H is normal, lowercase h is hemophilia. So her genotype would have been X, capital H, X, lowercase h. She passed this trait. She had, let's look at how many kids she had. She had 1, 2, I need to make sure my sound's on. 1, 2, 3, 4, 5, 6, 7, 8, 9 children. 2 of her daughters are carriers, and 1 of her sons has the disease. And these are the royal houses of Europe. So over here is the English house. We have the Russian house here, and one of these is Dutch, so, or Belgian. I think it might be this one over here. And then I think they might have some of the Greek family here. But you could see, so her grandchildren then had 3 sons that were afflicted and 3 girls that were carriers. And if we come down into the 3rd generation, look at all of these boys that had hemophilia. We have 1, 2, 3, 4, 5, 6. So it was all because she was a carrier, and then these houses intermingle. But what do we see here that tells us that this is a sex-linked trait? First of all, pause the video, see if you can figure it out. All right, welcome back. Did you say that everybody who has the disease or has the trait are male? There are no females that have it. So on a sex-linked trait, the members who are positive for the trait, the members of the pedigree who have the trait are males. So you can tell something is sex-linked when everybody who has the disease is a male. 2, we have female carriers. And 3, look what happens. So if you look at an individual family, we have a father that has it, and then nobody in this generation. So here we have a positive, he has hemophilia. But then in the next generation, we're negative. Nobody in this generation has it. And then we come down to this 3rd generation again, and we're positive. The other thing about a sex-linked trait on a pedigree is it skips generations. It skips generations. So just as a reminder, humans have 46 sets of chromosomes. So we have 46 chromosomes. that are set up in 23 homologous pairs. The last pair, so pair 23, is the sex chromosome. But pairs 1 through 22 are autosomes. And if we have a genetic trait that is on pairs 1 through 22, we don't have to worry about writing the base X or the base XY. Males and females are the same here. So we're just, if this was a trait was autosomal, we would just write HH or HH or HH because it's the same. So it's the same male to female. There's two possibilities we can have. We can have a disease or a trait be recessive, or we could have a disease or a trait be dominant. That is actually a possibility. And so let's grab the pedigree we looked at yesterday and see if we can figure out what kind of trait that is. All right, here's in the last video. This is the pedigree we looked at in the last video. So what do we have? First of all, the first thing you want to look at is who has the disease. So here we have a male, and here we have a female, and here we have a female. So right away, one of our tip-offs is, let me tell you, pause the video and see what you can figure out here. Analyze this pedigree, see if you can figure it out just by studying it. Okay, did you take a second and look at it? So the first thing we want to look at is we have 2 females and 1 male that have the disease. So that tells us that it's not going to be sex linked because we actually have more females than males. So this tells us it is not sex linked. So now the question is it recessive or is it dominant? Well, if it was dominant, anybody who had a copy of the gene would have the disease. But here we have carriers. So because we have carriers and we know it's not sex linked, this trait has to be autosomal recessive. Autosomal recessive. So if we were going to use N for normal and lowercase n for sickle cell, we would see that these guys are NN, NN. Heterozygous would be capital N, lowercase n, and these guys would be NN. And if you look at the Punnett squares, you would see that that works out. But what are our tip-offs for autosomal recessive? One is our male to female ratio. We have equal amounts. That tells us it's whether it's sex linked or not. And then 2, do we have carriers? All right, what about the third possibility? So let's look at one more pedigree. Let's bring this in. All right, I want you to take a second and I want you to analyze this and see what looks different from the other pedigrees that we looked at. Okay, what did you notice? Well, first of all, there's no carriers. It's not that they left that off, it's just not been, it's not that they didn't hide or fill it in, it's that nobody is carrying the disease. You just have it. And also look at the number that are afflicted. It does not skip a generation. Does not skip generations. And number 3, we have a lot of positive, a lot of people that are positive for the trait. Lots that are positive for the trait. Well, it turns out this is, and it says at the top, autosomal dominant. So this is on an autosome, but it's a dominant trait. And the trait we're actually looking at here are freckles. So capital F means you have freckles. and lowercase f, you don't have freckles. So we know that everybody that does not have freckles has to be lowercase. So if that's the case, if these two are homozygous recessive, and if you have a copy of the gene, you have the freckle, we know that this mother has to be heterozygous, which is going to make her offspring heterozygous. That's another trick you need to be able to do. Look at the inheritance pattern and then fill in the genotype for a generation. All right, we are going to stop there. On the next one, we're going to do I'm going to do some practice, and we're going to pick up kind of a quick side topic. So that's the end of this video.